after introducing the concept of non-linear programming, now we are going back to problem number 8 and see how we can solve this particular problem. In this case, you can see that the manager would like to determine the most economic order quantity to use in purchasing the paper. And so definitely that is one of the examples that we can apply a non-linear programming model. And we will apply the formula that we discussed for economic order quantity model. Based on this question, we're going to create our model. And and here we have ABC University. And in this case, we're going to identify information which is provided, and you can see that we have the demand, which is the amount of the boxes of paper to be purchased in a year is 24,000. And so the annual demand is 24,000. And then you can see each box of paper costs $35. And so that is cost per unit, which is $35. And then we have cost per order, which is $50. And then we have the holding cost, which is 18%. Cost, that is 18%. Now, in this case, we can find the order quantity. This will be our variable cell. And so in this case, we can put any value, either 0 or 1, or any value you may choose. So I'm going to put just 1 there. And then we are going to focus on the purchasing cost. And then cost of ordering. And then we're going to look at inventory cost. And so that will help us to find the total cost. So let's see, how do we find the purchasing cost? We're going to use the function, so you can put equal sign, and this will be cost per unit times the annual demand. And we can enter. So if you're going to go back to the model, you can see we are looking for the DC. Now, cost of ordering will be the annual demand divided by order quantity times cost per order. Inventory cost will be the order quantity divided by 2 times cost per unit times holding cost, which is 18%. And the total cost will be the sum of all this: the purchasing cost, cost of ordering, and inventory cost. And if you go back to economic order quantity model, you can see that we have applied this formula. This will be the set cell. Next, we're going to use solver to find the optimal solution. So you can go to solver, and in this case, the set objective will be the total cost. And in this case, we're going to minimize cost by changing variable, which is the order quantity. And then we're going to add constraints, and constraints will be the order quantity. So order quantity should be not 0, but should be greater or equal to 1. And that means at least an order is placed during the year, which will be non-zero order. And so in this case, the quantity should be greater or equal to 1. And I think that's the only constraint we have. And so we're going to click OK. And in this case, we're going to use GRG non-linear algorithm. And so you can click solve. And you can see that all constraints and optimality conditions are satisfied. And so the order quantity should be 77.768885. If order quantity is supposed to be integer, then we have to apply the integral condition. And so we can go back to solver and apply the integral condition. And so we can add in the constraint that the quantity should be integer, and then we can click OK. And then we can go to options, and then we look at the integer optimality percentage, and so we can put 0 and click OK, and then we can solve. And so you can see that the order quantity should be 78 instead of 77 point. And so this is the closest amount at this cost. So our economic order quantity should be 77. And that is the solution to the problem that we have.